Hello and welcome to Erudite. In this video we're going to be coding up this little assembly which allows us to effectively reconstruct a network and use that network to measure a path or to get a path from one node to another. This is just a fun little visualization for coding and hopefully will help you explore networks in our future videos as well. As usual, if all you want is just this piece of code to play about with, or indeed to adapt and use for yourself, it's available on my GitHub and the link is just in the description. And otherwise, let's get started with making this. I should say as well, if you want to code along with this video, please feel free because I'm going to go through it in nice stages, and while we're going to have a look at initially quite a big chunk of code, then what we're going to do is adapt it and improve it in nice little stages. So the first thing we're going to have a look at is just a super simple way that we can visualize nodes and the connections between those nodes in Pygame or using Pygame. And so this piece of code that I have here is just a really simple implementation, and the reason I've just jumped to showing us this code is I was tinkering around with how to do this, how we would look at it and how we can make it really nice and adaptable. And this was just my first pass, like having a little play around. And what I did was I had Pygame, the import, and we're going to be using randint just to help place in random positions the nodes. And then we had a network map here. And it's slightly different to the one we've looked at before in that in this case, but all paths or all edges between nodes go in both directions. So from A to B, we'll also go from B to A. And that becomes a little bit important when we look at pathfinding. Now, we introduce this class here, which is just a really simple class, node, and we initialize it with a label, an X and a Y coordinate so that we can get a position, and a radius. And we also have this value here of connections, which is set to an empty list because we can populate that after we've established all the nodes. And in fact, the reason I wanted it to be an empty list rather than just taking these lists here and populating them into connections is so that we could use the node object itself in this list. And that makes it much easier to refer to node properties such as the label directly when searching this connections list. A bunch of boilerplate here of initializing the Pygame library or modules. Then we set a width and a height for our window, and of course you can play around with that as much as you like. And we have the screen, which is just our display surface that we're going to place things on, and captions, clock, font. I didn't set any special font here, just used the basic Pygame font. And then what else do we do here? The background surface with its color, it's this dark grey. And then we come down to here where we're wanting to create our nodes using the network map, using this up here. So the way we do that is we iterate through that dictionary, that adjacency list, and for every key in it, so for every one of those nodes, we'll append a node with the name of that key. It'll have a random position based with an X coordinate, between 0 and the width, and a height coordinate between 0 and the height, and a radius of 15. And then after we've created all of those nodes, we can go through them and use the connections. I'm not particularly happy with this. It's not the prettiest piece of code, and we'll see improvements for that later. And then what we have is our loop where we say while true, and this is just a bit of code that allows us to exit by pressing the X button on the window. We blit our background to the screen, nothing special there. And then what we do here is we use the connections list in each node to draw a simple anti-aliased line with this sort of lightish grey colour between the node position and the connected node position. And we do those first so that we can overlay the nodes on top of those lines rather than have the lines at the front of the screen. And after we've done those lines, We then go through with the nodes, drawing them as circles, and then placing a text, as I was going to say, with the node position and node radius, and then we place text on those using our font object, and we just create a text rectangle with this text object, and we center it to the node position, and then we blit it to the screen. Let's just run this piece of code. It's a super simple piece, and then we're going to see problems with it and how we're going to improve it. Python network visualization.py, and we run it. Hey presto, we can see that we've got our network displayed. But it doesn't take a genius to look at that and go, well, that's horrible and not clear. And that defeats the point of wanting to visualize our network. And this sent me down a rabbit hole that I really want to explore later, because it's a super exciting problem of how to present a graph, how to get a computer to basically understand what is a good visualization of a graph or of these nodes or a network map that's human readable. We're going to be able to make these nodes draggable, so we can just move around the nodes to create the network visualization that we want to see. Let's see how we can improve the piece of code we've just looked at to be able to carry out this function. So one of the first things I want to do is actually create a new file. I'm going to call it classNode.py, and we're going to take the node class out of this file. I always like to do this. It's much neater just to separate things out a little bit. And we can delete that from there, but we're going to have to put into here from class node import node. One of the things I'd like to set up is this a property that's going to be called isMobile. And if isMobile is true, then we're going to be able to move this node. We're going to have something called update position. And it's going to accept a point, which will be the mouse position. And if self.isMobile, so that means if it's true, if self.isMobile is true, then self.position equals point. So it just moves to where the mouse pointer is. You're going to need a way of making the isMobile property to be true. So we're going to have an update mobility, and that's going to accept a self, and it's also going to accept a point, because in this case we're going to want to know if the mouse is over our node when, say, it's clicked. So we're going to want to be able to test if the mouse position is over that node, and there's a really nice way, or a really easy way we can do that using the Euclidean distance function that I think I've included in a whole load of videos now. So we'll just pull that in a moment. But what we're going to want to do is say something like if self is selected. So we're going to have to write this function. We're going to put a point in there. Self is mobile equals true. And all this means is that if the point is over the node, when it's clicked or when this event occurs, then we need to switch is mobile to be true, so that now that node is mobile and can move around. So now that gives us another function that we need to define, which is selected. And that's going to accept self and a point. So what we're going to want to do here is basically use the old Euclidean distance function, and it's going to accept the position of this node, so the object itself, and the point. And if the distance between the point and the center of the center position of our node, if it's less than the radius, the self radius, then we know that the mouse pointer will be within the circle, so that we should make that node mobile. So we're just to say return true. Otherwise, return false. So if we run it through here, it'll only return true if we have that point selected. I just want to go and grab the Euclidean distance function. So there's our Euclidean distance formula, which completes our node. And now we need to make use of some of these functions to actually be able to move our node. So the next thing that I want to start doing is make a new file. And we're going to call it class network. And that's going to hold a network object. And basically I want the entire network to be managed within this object. So what we'll do is start by defining it or initializing it. We'll have an init function where we'll take self, and it'll need the network map in order to create all of the nodes, but we'll also need the width and height of the window in order to randomly place that initial set of nodes. So what we'll do is we'll initialize the nodes. I'm going to store them in a dictionary because I want to be able to access them by their label. So search through them or just call it using a key, which is the label. So self nodes, we're going to create an empty dictionary, and then for key in network map.keys, we're going to create or add nodes with the same key. So it's going to be equal to node, which means, of course, we're going to need to import from class node, import node. We're going to have the node here, and we're going to pass it key. I can't quite remember what we need to send to it. A label, an X and a Y and a radius. So I'm going to need the random function as well. So from random import randint. This just allows us to select a random value, and that will be between 0 and width for the X coordinate and 0 and height for the Y coordinate. And then we'll just have 15, I think, for the radius. So when we call this with the network map, we should initialize all the nodes. So let's check that that works. We're not needing class node anymore, we're needing class network. And we'll put network here. And within this, rather than making our nodes, what we can do is say network equals, and we'll use the network object, and we'll pass into it the network map, the width of the window, and the height of the window. I think that's the right way around. Width and height, lovely. And so we should then be able to use this object to refer to the nodes. So these lines won't work, but what we want to do is see if it renders the circle for the node in the right place, or just, a set of nodes with the correct letter on. So instead of for node in nodes, for key in network nodes.keys, like so, and then we'll have to refer to things in a slightly long-winded manner, but it'll be network.nodes with the key, so that we're referring to the nodes within the network. And we can use that same bit here. It does make it a bit long to read though, and a bit annoying, but it'll do for now. If I make this full window, There, that might be a little clearer, so that we can see the whole window of what's going on here. And we have another one down here, which we need to refer to as network.nodes key position. So let's run that file and see what happens. There we go. We've got A, B, C, D's up there, I think E, F, G and H. Lovely, so it's creating all the nodes. Seems to be working. So there's a couple of things now we're going to want to be able to do if we want to move things around. And that's going to require me to have some kind of flag to say whether the mouse has been pressed. So what I'm going to do is create a variable called mouse down, and it'll be equal to false initially. But then we're going to have a look at our inputs from Pygame, and we're going to say that if the event.type is equal to mouse button down, then we're going to say that mouse down is equal to true. We're going to want to perform some kind of update, so using the mouse position. So we're going to say mouse position is equal to pygame.mouse.getPosition, and we're going to have to write a function where we use the network class to update all of our nodes dependent on both the mouse position and the mouse down variable. And after we've done that, we want the mouse down to reset after this cycle. So we'll say that mouse down is equal to false at this point. So we sort of reset it. So let's save that, and we'll go back to our network file where we want to have a look at how we can use an update function. So we can define update. It's going to take self and mouse position and mouse down. So that's just our flag before. So if mouse down is equal to true, or we could just say if mouse down, if the mouse has been pressed down, we're going to want to check the mobility status on each of the nodes and see if the mouse was over any of the nodes, and if it was, set that node to now be true for its mobility so that we can move it around. So if mouse down, then we're going to say for key in self.nodes, in self.nodes.keys, self.nodes key dot update mobility. And I believe that function required required the mouse position. So we can send the mouse position to that function. And so what that will then do is for each node in the network, it will check to see if the mouse, so using this is selected here, to check if the mouse is over this node. And if it is over this node, it will set is mobile to true, and we can then move the node around. Now if this is no longer, if mouse down isn't true, then we can still use the mouse position. We can use else, and we can do exactly the same bit of code here, except we can update the positions of the nodes. We want to be able to move the node with each frame. What we're going to do is write a brief function in here that we can call, which is something like mobility reset. And all we're going to do in this is say that we can copy this bit of code. We're just going to reset the mobility on every node. So we'll just say is mobile equal to false. And we're going to have to use that function with a new input. So if event.type is equal to mouse button up, then we're going to want to say that network.mobility reset, and it will just perform that reset So let's save these files. Don't think I changed anything here. And run it and see what happens. So if I hover over here, yeah, there we go. So I can move these points around. So I can drag them off from the borders there. That's fantastic. That's working really well. So now something I want to deal with is this code aspect down here, where we're not able to look at the connections because we haven't put them in yet. So what we want to do is make sure that we change that, and we can add into this network. I'm just going to put in another argument that we send when we're creating the node. We're just going to call it network map, and then we're going to put key in there. So that what we're doing is passing, if you have a look back at our network map, we're just passing this list to the node. And what we're going to do in the node is take that as called connections, and we're just going to set that equal to connections here. So as before, we're just going to say for key in network keys, just like this. We can copy that and pop that in there. And we can say for node in network.nodes. So we're looking back at that bit, and then we're using key to refer to the specific node. And we've got this connections property within that class. We can draw points between them. But it is a bit faffy to have to write it out like this each time. So we can just say, we can use our node position is now this, because it's at that specific key in the nodes that we've got that position. And then we also have this node here that we can use to refer to our value again, like so. Now we should be able to see the lines between each of the objects. So let's have a look at that. And there we go. We're able to drag this around like so and reshape it as we want to make a better graph. Much nicer than what we had before and much more flexible. But we want to add a bit of functionality into this, so that we can do things that are a bit beyond what we're looking at here. We want to be able to do pathfinding. So what I want to do is create states within this program, so that when I press spacebar, I can switch between the mode where I can just move things around and a mode where I can click on two nodes and get a path between them. Right, so one of the first things we're going to want to do is see if we can effectively switch on and switch off the ability to move around the nodes. And so what I thought would be a good way of doing this is having a flag within the network class where we can basically switch between the states of what we're doing. So we can say self is editing and set this equal to true, but if we're then doing something else, we can set this equal to false. So we can only move things around if we're in that state. So we could also add it here and say if self is editing and mouse down, so we've basically got this control, then we'll do the update mobility. But now we can make this bit here a bit more precise. Elif self is editing and mouse and not mouse down, so that's not true anymore. Then we'll update our position. So these events are only going to be occurring if we're in the self is editing state, if this is true up here. And we can also set some controls within the main file or within this network visualization file. We can add to this here a flag where we would say something along the lines of if network is editing. So it will only change the state of this boolean if we're in the editing state. Otherwise, we won't change it at all. And then what we can do is here we can make this specific so that it says if network is editing, then we'll do this network mobility reset. Otherwise we don't need to touch it at all. So this is a really nice way of controlling it. But we also need a way of switching between the state, or switching the state on and off. So what we can say is if event.type is equal to, is it key down, I think it is, no, pygame.keydown, sorry. Pygame.keydown. And if that event.key is equal to pygame.k_space, so if it's the space bar that's pressed, then we can say that network.isEditing will be equal to not network is editing. So it'll switch that state around. Let's just save that and have a peek to see if that works. So what we're expecting behavior-wise is that when we press spacebar, we can't move things around anymore. So we can move things around just like we could before. And now if I press spacebar, we can't move things. But if I press spacebar again, we can move things again. So we're creating just this simple way of switching between two modes, where we're using our mouse and the spacebar allows us to pick whether we're editing or, as we're going to do hopefully in a moment, setting a path. So how are we going to do that? Well, we can add another state here that we can actually switch on and off. And it will sort of be the opposite of whatever the editing is. And we can call this something like is selecting, because what we're going to be doing is selecting the points for which we're going to get the path between. And that will initialize as false. And if we're going to be having a path, we're also going to be able to, or we're going to need to store a start and an end position. But I'm just going to initialize these as none at the minute, and then what we can do is populate them with a value. And we're also going to need something to store the path in, but that can also be a none for now. It doesn't need to have anything in it just yet. And so what we've got is this little setup where we've got a state or states that we can play around with, and we've got these variables where we can hold our start and end for a path, and then the path itself. And the way we're going to get this path is using the functions we wrote in the previous video, where we looked at using BFS and DFS to get a path. So we can say elif self is selecting. We're going to want to do something different when we update. And we're also going to want to take, well, we might not take the same variable, we might get a different variable that we could call something like start end, or find start end, or something like that. Let's just leave it as start end for now. And then what we've done here is we're now saying to the program, okay, but now you know that somebody has clicked something to get the start or the end position. But we want to see if they've actually clicked something valid. So is it even over a node? So to do that first, we're going to need to iterate our nodes, and we can just pinch the for key in self nodes.keys. And we can use the program we actually wrote already in Node. This is selected. We can use that independently to find out if the mouse is over that point. And because we have the mouse position here, we can just use that directly. So if self.nodes, and then we want key dot is selected, then with mouse position, then we want to check if self.start is equal to none. If it is equal to none, then we set self.start equal to the key, because that's obviously the node that the user is hovering over and clicking, because they're wanting that one to be the start. else it's the end, because what you're going to see is we don't actually hold on to the start and end. As soon as we've got an end, we give the path back. And then we want to break because we don't want to keep searching and keep overwriting anything that we've done here. We just want to break off and not look through any more of the keys. We can finish off this update function, which is a little bit messy. I should tidy this up really. If self.start and self.end, if they're both set, so neither of them are equal to none, then we want to get the path, and we'll set self.path equal to, and we're going to have to just put a placeholder at the minute, like find path. And we're just going to leave that like that. Don't worry, we're going to come back and sort these bits out in a second. But we also want to set self-start equal to none and self-end equal to none as well, because we're not going to want to hold on to those values. We basically want to give you that path back, display that path, and leave that path displayed. And then if you click another one, it will take that as the new start, and another node, it'll take that as the new end and give you that new path, deleting the old path. So you can constantly be checking new paths as you're going along. And what we're just going to do is write down here def find path. Actually, we might as well finish off adding that into this function. So what I'm going to do now is I'm just going to copy and paste a big chunk of code that's into this section here. I say big chunk, it's 28 lines, but hopefully you should recognize it almost straight away. Apart from the self at the front here, and the fact that this one doesn't take the network map anymore, because it can just refer to the self.nodes directly within the network object, these three functions here, search, find path and build path, were what we wrote in the previous video. So in the previous network video, when we looked at the BFS and DFS for finding paths within networks, these were three of the functions that we came up with, and they're really, really powerful functions. So we're using them here, and all we're doing is just applying some of the class utility where we can refer to things directly, like self nodes, and you can see down here I've done that rather than have to pass things through continuously. But what we get out at the end is the path, or we get a non-object where you just won't get anything shown. So if you click on two things that aren't connected, it won't crash the program. It would probably be quite good if it put a flag up or like a value on the screen that just said no path found. But for now we're just saying return none, so that it doesn't display anything, and therefore you know there's not a path present between those two things. But otherwise you get the path, and we can work with that. So, I need to just update this so that we've got all the values that needs to go through. So that would just be self start and self end. So within the main file, we're going to need to have that start end value that we had before, and it's going to be initialized as false, just like the mouse down. But we need to have a setup whereby we set that to true. And that's only going to happen once when we click while we're in the is selecting state of the network. So in this mouse button up, that only happens once when you press a mouse. So when you press it down and let it go, you only get one flag of this event. We can say that elif network dot is selecting. There we go. I can type, I promise. Network is selecting, then we can set start end equal to true. Now let's just save that a little bit there. We also want to have a play around here, because not only do we want the network is editing to go to not editing, but when we press space we then want it to also switch on the is selecting. So we could just say selecting is equal to true, but that wouldn't be very good, because every time we press spacebar then it would set is selecting to true, even when we were wanting the is editing state to be true. So what we can do is say network is selecting is equal to network.isEditing before we flip the state of the network is editing. So when we're editing, it will be true at this moment, and we set is selecting to true, then we set the is editing to false, or vice versa. So we're always just flipping these two states. Now, what else do we need? Oh, and also, whenever we do this, I just, for ease, want to set the start, the end, and the path all back to none. So it doesn't matter what we're doing, we basically go back to a clean slate for that search function. And we can save that bit. And we need to add the path, we need to add the values down here, down in this section here, of that start end. And we also need to set start end equal to false after we've used it. So what we want to do is add into our network update start end. And did I end up using it? Yikes, I may have mistaken. Oh no, here. So I already had it here. This would have been a big error. But I hadn't yet accepted it as an argument into that function. So let's save that, save that. We want to show our path here. And we want it to be in between these two parts, because if I just add a couple of comments here so it's easier to see, this is, we're displaying the connections between the nodes, and this, we're displaying the nodes and their labels. So effectively, we don't want to have the path in front of the nodes and labels, because that will make it harder to read them. We want it to be, though, in front of the actual connection, so it's like overlaid on those things. So we're going to pop it here. So what we can do is check first if there's a network path. So this will return false if the network path is equal to none, so it just won't generate a path at all. But if there is a path, then we want to show it. So for I in range of 0 to length of the network path, actually I need to be network path -1, because what we're going to do is draw each of the connections. So we're going to start with the 0 point, and we're going to connect it to number 1, and then we're going to draw number 1 and connect it to number 2, and number 2 and up to number 3. But if we finally get to the end one, we don't want that to connect to something new, because there's nothing there, and we'll just get an error of an index not being inbound. So then we can work out our position A, and this is just to make things a bit neater. It will be network.nodes, network.path, and that will be at position I. So we're using the path to get the letter out, so that we can then use the dictionary feature of the network nodes object. So this will give us like our A, B, or C, and then because we're plugging that into the dictionary, we now get access to the object, and then we just want the position. And for position B, it's pretty much identical, except it's I plus 1 instead of I. And now we want to draw it, so we go pygame.draw.line to the screen like so. And I think I was going to go for yellow, which is with RGB 255255 and a 0. And then we just want pos A, pos B, and make the line thickness 5. Because we want nice thick lines when we're doing that. And I think that will be done. So we have this nice little interface. We can still move things around. Let's have it like that. Just drag these about a bit so it's just a little bit easier to see what's going on. And then we press spacebar, and now I'd quite like to see the path between E and H. And there we go. Maybe I'll pick two different ones. Let's have F to B. There we go. G to A. So we're able to get this path really easy just by clicking on the nodes that we're interested in, like so. But then if we want to move things around again, I just press spacebar, and now we're back into the editing mode. And so I can move things around and have a bit of fun like so. And then we can go back to the pathfinding and go, okay, what's the best between these or these? And it's super, super easy. I'm really pleased with this little program. But that about wraps up this code. This is just a nice bit of fun to explore how we can visualize these networks. I hope you've enjoyed it. In future videos, we're going to continue playing with this, and we're going to use this to help explore different pathfinding algorithms. If you did like, why not subscribe? If you've stayed this long, you might as well. And I'll see you in the next one. Bye!